Welcome to our course on the future of technology in Agriculture 4.0, where we explore the exciting possibilities and transformative impact that lie ahead. In this session, we will delve into the emerging trends and advancements that are set to revolutionize the agricultural landscape and shape the future of farming. Over the years, technology has reshaped farming, and technical advancements have had multiple effects on the agriculture business. Agriculture is the primary occupation in many countries around the world, and with a growing population, which according to UN projections, will increase from 7.5 billion to 9.7 billion in 2050, there will be increased pressure on land, as only an additional 4 of land will be cultivated by that time. This means that farmers will have to accomplish more with fewer resources. According to the same study, food production will need to expand by 60 in order to feed 2 billion additional people. However, traditional technologies are insufficient to meet this enormous need. This is compelling farmers and agribusinesses to develop innovative strategies for increasing production and decreasing waste. As a result, artificial intelligence (AI) is steadily evolving as part of the technical evolution of the agriculture business. The challenge is to boost global food production by 50% by 20,502 in order to feed 2 billion additional people. Not only will AI-powered solutions help farmers to increase efficiencies, but they will also boost crop yield, quality, and time to market. AI with the ability to interact with the real world, to perceive, solve new problems, plan, and make decisions in the face of unexpected problems, continuously learning uncertainties, and adapting, has increased in popularity as a result of increased data volumes, advanced algorithms, and advancements in computing power and storage. AI is all about mimicking and encoding human intellect into machines so that they can execute similar tasks as humans. The ideal characteristic of artificial intelligence is its ability to identify and define actions based on their probability in order to achieve complicated goals in the most efficient manner. The robots achieve cognitive skills, such as sensing, learning, and reasoning, and are able to solve issues like a baby who is just beginning to learn to classify and recognize objects. Popular applications of artificial intelligence we find in the financial sector include fraud detection, self-driving cars, agricultural tractors, drones and robots, IoT, supply chain, health, education, analytical programs, decision and expert systems, and smart assistants, such as Alexa, Siri, and others. With machine learning (ML), natural language processing (NLP), and deep learning as the revolutionary subsets of AI, the most distinguishable categories of AI began to emerge. Weak or narrow AI is a sort of AI capable of performing a specific task intelligently. It is the most widespread and prevalent AI form now in use. Narrow AI is only capable of performing the task for which it has been trained, and it fails outside of these parameters. Examples include Apple Siri, chess playing, e-commerce suggestions, self-driving cars, and IBM's Watson supercomputer. General artificial intelligence is the type of intelligence capable of doing any intellectual work as effectively as a human. General AI's fundamental goal is to imbue machines with human-like intelligence and the ability to think independently. Current artificial intelligence, AI, and research in the 21st century are at this stage. Additional time and development are necessary to get beyond this stage. Super A is the level of system intelligence at which machines surpass human intelligence and can execute any task better than humans. This is the result of general AI. Despite being a hypothetical concept at present, if it is realized, it will alter the world. The oldest form of AI, reactive robots, have extremely restricted capabilities. These have no memory and are consequently incapable of learning from the past. They have little ability to react. The first forms of artificial intelligence are just reactive devices. The Deep Blue system from IBM and AlphaGo from Google are instances of reactive machines. Machines with limited memory have storing capacity for a brief amount of time. They are capable of learning from previous data experiences, training, and performing the functions of a reactive computer. Diverse AI algorithms can be applied to vast quantities of data to develop insights and improve precision. The autonomous vehicle has a restricted memory strategy. The majority of contemporary AI devices of the 21st century employ a restricted memory strategy. Theory of mind AI is the next level of AI that is still under development, with no results to date. A theory of mind level AI will be able to better comprehend the needs, emotions, beliefs, and mental processes of the beings with which it interacts. AI computers will be able to recognize humans as individuals whose brains may be influenced by numerous variables, thus knowing humans, which in psychology is known as the theory of mind. The goal of AI research will always be the development of this form of artificial intelligence, which is decades, if not centuries, away from materialization. This form of artificial intelligence will not only be able to perceive and evoke emotions in individuals it interacts with, but it will also have emotions, wants, beliefs, and maybe desires of its own. Machines will have their own awareness, emotions, and consciousness. Moreover, technological pessimists are cautious about this form of artificial intelligence. This is due to the fact that once self-aware, AI will be capable of gaining concepts such as self-preservation, which might directly or indirectly mark the end of humans. Consequently, an entity can also cause catastrophes. Terminator and RoboCop are similar depictions of what this type of artificial intelligence could evolve into. Machine learning is a subset of artificial intelligence that gives machines the ability to automatically acquire knowledge via experience without being explicitly programmed. It includes supervised, unsupervised, and reinforcement kinds. It is the most prevalent and widespread application of AI in agriculture and beyond. Deep learning is a subfield of AI and ML that enables machines to do human-like tasks autonomously. It enables AI bots to simulate the human brain via a neural network simulation. Deep learning may train an AI agent using both supervised and unsupervised learning. AI includes also natural language processing, NLP. NLP enables a computer system to comprehend and analyze text or spoken human languages, such as English. NLP serves as an AI language tool incorporator. With NLP, human language may be utilized to teach and operate machines. Today, both AI and NLP are ubiquitous. We may easily request Siri, Google, or Cortana to perform tasks in our native tongue. Expert systems are computer programs that rely on the acquired knowledge of human experts, which is then programmed into a system. Expert systems mimic the ability of human experts to make decisions. These systems are intended to solve complex issues utilizing knowledge bases rather than typical procedural coding. One example of an expert system is Google's suggestion for misspelled words as you type in the search box. The field of robotics has evolved into the immensely fascinating field of artificial intelligence. This exciting sector of inventive work focuses mostly on the design and development of robots. Robotics is an interdisciplinary branch of science and engineering that combines mechanical engineering, electrical engineering, computer science, and a number of other disciplines. It strategizes robot design, manufacture, operation, and application. It administers computer systems for management, intelligent results procurement, and data modification. The use of computer vision that enables a machine to recognize an object is known as machine vision. Machine vision uses one or more video cameras, analog to digital conversions, and digital signal processing to capture and evaluate visual information. Machine vision systems are programmed to execute strictly defined tasks, such as object counting, serial number reading, etc. Computer systems may not see as well as human eyes, but they are not limited by human constraints and can even see through walls. Speech recognition is a technology that allows a machine to comprehend and interpret spoken language into a machine-readable format. In this form, a vocal command or spoken word serves as the input for a computer to perform a certain activity. There are speech recognition applications with restricted vocabularies of words and phrases. This software requires unambiguous spoken language in order to comprehend and execute particular tasks. There are currently a variety of applications and gadgets that include speech recognition technology, like Cortana, Google's virtual assistant, Apple's Siri, etc. Our speech recognition technology must be trained to comprehend our language. In the past, these systems were solely intended to translate voice to text, but there are now a variety of devices that can turn speech straight into commands. Every day, farms generate tens of thousands of data points on temperature, soil, water usage, and other factors. Using artificial intelligence and machine learning models, this data is utilized in real time to derive important insights, such as the optimal time to sow seeds, crop selection, hybrid seed selection to increase yields, and the like. Precision agriculture, which is aided by AI technologies, improves crop yield quality and accuracy. AI technology aids in the detection of plant diseases, pests, and nutrient deficiencies on farms. AI sensors can detect and target weeds before determining which pesticide to use in a given place. This results in lower herbicide usage and cost savings. Numerous technical businesses have created robots that utilize computer vision and artificial intelligence to precisely monitor and spray weeds. These robots are able to eliminate 80% of the quantity of pesticides typically sprayed on crops and reduce herbicide costs by 90%. These clever AI sprayers can substantially reduce the number of pesticides required in the fields, hence enhancing the quality of agricultural products and reducing costs. Predicting the optimal time to sow. The difference between a profitable year and a failing crop is timely information on a single data point of spreading the seed at the optimal moment. To tackle this, scientists employed a predictive analytics technique to determine the optimal date for sowing seeds for maximum yield. In addition to a 7-day weather forecast, it also provides soil health analysis and fertilizer suggestions. Predictions of crop yield and price forecasts. For many farmers, crop price fluctuations pose the greatest concern. Farmers are never able to set a definitive production pattern due to unpredictable prices. This problem is prominent in crops with a short shelf life, such as tomatoes. Utilizing satellite imagery and weather data, businesses are assessing acreage and monitoring crop health in real time. With the use of technologies such as big data, AI, and machine learning, businesses can detect pest and disease infestations, estimate tomato output and yield, and predict tomato prices. They can advise farmers and governments on future pricing trends, demand levels, optimal crop types to plant, pesticide usage, etc. Have you ever wondered who harvests the fruits and vegetables from the agricultural land? Well, in most situations, it is not traditional farm laborers, but rather robotic devices that are capable of harvesting in mass with greater precision and speed that are responsible for putting food on your table. These machines contribute to an increase in crop productivity and a decrease in waste of field produce. Many businesses are attempting to improve agricultural productivity. There are goods such as an autonomous strawberry picking machine and an apple harvesting vacuum device. These devices combine sensor fusion, machine vision, and artificial intelligence models to identify the location of harvestable produce and assist in selecting the appropriate fruits for harvesting. Agriculture is the second largest industry where service robots have been deployed professionally, behind the defense sector. According to the International Federation of Robotics, as many as 25,000 agricultural robots have been marketed, which is the same amount employed for military purposes. Agriculture 4.0 relies heavily on AI, and the benefits are vast. Examples of leverage brought about by the deployment of AI in agriculture include the exploitation of resources inputs as optimized as a result of AI's enhanced understanding of data gathered in the field. The AI algorithms perform an efficient analysis of agricultural data in order to generate accurate predictions. AI facilitates the efficient cultivation, harvesting, and sale of crops. The AI model renders disease identification a practicable process, hence enhancing the possibility for healthy crop production. In the era of Agriculture 4.0, artificial intelligence, AI, has been the backbone of agricultural industries and has promoted and increased new business opportunities greatly. The agricultural weather forecasting system has been radically transformed by artificial intelligence, and this plays a crucial role. Crop management procedures have reached new heights, and managing crops with least effort has become rather convenient for farmers. AI has brought answers to numerous agricultural problems, like as pests, weeds, etc., that have a catastrophic effect on crop output. The use of AI and big data has aided in mitigating the risks to nature by employing the most effective techniques to limit environmental exploitation. A greenhouse continues to be one of the most valuable agricultural methods. In terms of maintaining a greenhouse's appropriate functioning, AI methods have achieved considerably superior outcomes than manual operations. Every area of the industrial world and the agricultural revolution have been revolutionized by AI. Each day, additional ideas are discovered as a result of global curiosity and investigation. This chapter addressed the fundamentals of AI, including how some of its features and types function. Thank you for joining us as we explored the promising future of AI in Agriculture 4.0. As we continue to embrace the power of artificial intelligence, we can envision a world where farming becomes more efficient, sustainable, and productive. Let's work together to unlock the full potential of AI in agriculture, revolutionizing our food systems and creating a brighter future for farmers and our planet. And remember, individually, we are one drop. Together we are an ocean.